Good evening, Mon.
Good evening, good evening.
How are you?
Excellent, excellent.
Noise is very feeble. I cannot hear.
Music Salvana.
Ha.
That is why probably.
Okay. I hope you have received relevant data.
Yes, I have received everything.
Okay.
Gopal, good evening.
My video is still not working. He is going to allow after some time.
The video is working, but you are looking black.
Acha. Okay. Arey, you have changed the style, na, Gopal? Good. Niranjan is not going to come today?
Niranjan is in travel, na?
Okay.
I think he is coming from Ratnagiri, so he was late. So he is in travels. He may not be able to join.
Hello, Uday. How are you? Ha, माझा मित्र Uday.
Yeah, Uday. Good evening, Mr. Uday.
Uday, can he be able to hear or possibly hear?
Now, yes.
Okay.
Hello. Yes.
Yeah, Uday. Good evening. How are you?
Good evening. Fine, just fine.
So he is Dr. Yogesh Pawar.
Okay. Hello, sir.
Hello, how are you doing?
I'm good, sir. I'm good. I'm doing fine.
Wonderful. Thank you very much for supporting the entire community.
It's my pleasure, sir.
I remember Anandji speaking very highly about you and Atrey sir as well. So
He must be speaking highly about Atrey, sir, not about me. I'm his jigri dost.
Both of you, na?
that's part of it. I think people are joining in as a time. We could probably have our discussions going around. There are certain. Has Atrey sir also joined? No, he's joining at 7:30, right? Okay.
He's joining on 7:30.
Okay. Great. So it's our 75th year of independence. I think it's a great way to have a core technician on the talk today. So probably tomorrow morning, day after tomorrow morning, of course, we'll be 75 years young country.
By the way, Yogesh sir, he is also expert in heat exchangers.
Oh, is it? Wow.
Which is closed, which is nothing but cooling towers. And
Yeah,
he has already won. I was just going through his profile on Google. So he has got a Sukhatme award. And Sukhatme was a wonderful professor who wrote an excellent book, which was as a textbook for the engineering college in the third year.
Wow.
And I'm sure he's all heat transfers, heat engineering. He's expert there.
I'm sure you'll have a lot of questions today.
I will. I have already noted a lot of questions.
Very good. The best about the community also is that when we see that there are people who have pedigree coming in, it becomes very easy and exciting to actually get into it. Unfortunately, I'll not be the part of the entire event. But yeah, I have already given my reason, which is a very genuine and honest reason, I think.
Yeah. And you are probably, I won't say excuse, but yes, you are allowed.
I'll have to move out, but yeah, I'll at least meet him, greet him, and then probably just let me check if
he has also worked with SINE, SINE. I think that is something which is Society for Innovation and Entrepreneurship.
Oh, wonderful.
So he can contribute a lot to the community.
Is it? Udayji
Yeah,
wanted to say
he has
something.
worked as an
Udayji, you wanted to say something.
Yes, actually, he was in charge of the sign.
correct.
Before he was promoted as a Dean of R&D. And Dean R&D is a post for which the tenure is 3 years, which will be ending shortly. But he has signed, he's been in charge for so many years. And he will encourage definitely if anybody wants anything of help from the sign, I'll be glad to associate myself and help. We can get an assistant from Professor Atrey.
And sign will be really useful for all our RISE members.
Yes, definitely.
Yes,
Yeah.
yes.
Should we have a question answer session type, or should we hear from him first and then have interactions? That you decide.
Actually, as per Amit, he's going to have some presentation on this oxygen solution, which he has done a lot of research. And
Correct.
after that, we'll have question and answer.
Okay, fine, no problem.
So that innovation it was well appreciated by the entire society, government, and everybody.
Correct.
So after that, we'll have question and answer. We'll hear about that oxygen solution.
Okay. Should we start at 7:20 or 7:30?
What is the time? No, so
This is 7:19 now.
No. I'm saying we will start according to the plan. Whatever is the plan, we will start. The questions like these create doubts in people's mind. So whatever is the schedule, we will follow that. Whether it is 5 people,
Amar is controlling, na?
Amar is controlling. There is whatever is. These questions are very dangerous.
Okay.
And so my request to you is please not to
7,
use this
let us start at 7:20 sharp.
Correct. There is a plan. We will start executing the plan. Period.
Yes. Amar, are you ready?
We are supposed to start with national anthem. Yeah.
Yes, national anthem. We will start at 7:20.
Correct.
This is 7:19 now.
Yeah. Mr. Uday is in which line?
Pardon?
Mr. Uday?
Hold on.
Yeah, we'll start now.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे
भारत माता की
Jai.
Amar, you can display the oath. We can start further. Good evening, everybody.
Good evening.
Let us recite the Arise oath after me. I am a responsible human being,
I am a responsible human being,
ready to support,
ready to support,
share and collaborate.
share and collaborate.
I'll be honest in my actions towards everyone.
I'll be honest in my actions towards everyone.
I'll enjoy my journey
I will enjoy my journey
with a large heart and tolerance
with a large heart and tolerance
towards Arise community and society.
towards the right community and society.
I'll establish
I'll establish
entrepreneurial brotherhood
entrepreneurial brotherhood
to strengthen my country and humanity.
to strengthen my country and humanity.
Jai Hind.
Jai Hind.
Over to Mohanji.
Yeah. You can stop.
Yeah, now if we want to display or say something from our member, anything for next 10 minutes, we have this particular slot but
Actually, a quick 5 minutes presentation is planned by Dr. Yogesh. I can display this presentation.
Please, sir.
Yeah.
please.
Can you see the screen?
Yes.
Yes.
You can just full screen it.
Yeah, I'm just making it. Yeah.
Yeah.
Can you see now?
Right. Yes.
Yes.
Thank you very much. I hope people are able to see me and hear me.
Yeah.
Thank you very much, all of you, for joining in. RISE as a community is strongly based upon sharing, collaboration, and learning. And keeping these values in mind, keeping this ethos in mind, we conduct a lot of events digitally now. Most of them are digitally, but also before the pandemic, a lot of physical events used to happen. And one of the event was called as Night of Truths. Night of Truths is where businessmen who have created over 1,000 crores plus businesses come and share their learnings and as friends, as the journey that they have gone through, the difficulties that they have gone through, and people also share the amount of the question answers that you can directly ask them, and they give you solutions. Every year we conduct an annual operating plan for all our members, and it's a physical event. Even this year we did that, and over 100 members were a part of this, and we saw a lot of traction where people are able to plan their businesses for the entire year. We do monthly synergy meets where we call influencers, technocrats, government officials, bankers, investors, decision makers to boost the immunity and of our businesses. A new information keeps coming in, and we start working on. So today, one of them is Tech Talks, and we are going to interact with one of the legendary, technology person from IIT Mumbai, Professor Atrey. And I'm sure all of us will learn a lot from it. We have free webinars from experts to understand overall business understanding of 360 degrees and stuff like that. Next, these are certain events that have happened. Our foundation day happens on 1st of May, and this time it was Mr. Partha and Mr. Atul Srivastav, who came in and discussed about two elements of business. One is project management, second is funding. So that is what happened. Sir, can we move on to the next slide? This is a very unique service that we offer to our members, which is called Arise Recovery Clinic. Arise Recovery Clinic focuses on the money that is stuck of our members. We tend to get the solution out of this through Arise Recovery Clinic. Advocate Anand Mahurkar is a member, and he's foresighting and giving all these services to people. We also see certain sessions. One of the sessions that we did was how to live a tranquil life, which is life, heart, and mind in action together. And this was an open program for entire family. I think over 200 people joined this webinar as well. Let's take to the next. We also give more opportunities to our members. One of our member, Ryzen, is Anand Paranspe, and he was the chief guest. We call him for self-assessment of trade, international trade, where he worked with his experience. He was able to share why we are not able to do the international trade. This was Night of Truths, where we had Mr. Narendra Pawar, who created $1 billion business out of rural India. And how did he do that? By incubation. Next, we have, we also as a community focus on a lot of spirituality. I always say the journey of a businessman is all about emotions and economics, right? So in order to maintain the right emotions and the right emotional balance in his life, we very recently invited Swami Mukundananji, who spoke about the 7 divine laws of how you can be the best of yourself. Welcome, Atrey sir. Thank you very much for joining in. We do yoga sessions early morning, every twice a month. Sir, next one. We're doing a very good developmental project of developing 8 girls who are a part of, that's called Project Manavya. It's called Project Vijayashri typically.
Yeah.
Project Vijayashri is where we are developing 8 girls are very young, 18, 19 years old, who do not have the economic background, and we are helping them to become business women, business ladies, and these are certain images that you see of that project as well. They are now reaching towards bigger goals, wanting to do bigger things. This is how we are enabling technology. We had called in people from L&T to help our SME members to do better things in their businesses. Sir, can we move next? These are certain events that we did in June and July. Swami Gyanotsalji ji, who is the Pramukh for the entire Swaminarayan temples, he was there. He spoke about life lessons and business lessons. We had Madhav Ganpuli ji, who is a very, very eminent personality when it comes to finances, on Fund Talks. Certain benefits which I think every community gives because of the members that we have. We are a like-minded group of people. We believe that the more you give is the more you get. We don't count who is getting how much, but we ensure that giving happens. We do a lot of collaborative bargaining where people, where we pick up a lot of common things that people want, and then we go and negotiate it with people. Arise is a very beautiful online platform where you can actually showcase your businesses and display your ads. Where online you have your own membership, you fill in all your details as a business, and you can do that as well. Business mentoring happens from the senior business, businesses who are there. One of the operation that we do is called Operation Reboot, where we ensure that any business that is stuck up in the community, of course, we are trying to help them and make them better. Preferential rates are given for all Arise events, brand promotions, showcase businesses. Every synergy meet, we have 3 business presentations that happen where people are able to showcase what they do. This is the kind of work that we're doing for all the members who know it, for all the members who don't know it. And please avail all these services. You can get in touch with Mr. Amit Deshpande, who's the office bearer, or any of the trustees. Of course, it's a non-profit organization. We all are there to support you. With this, I thank you for giving me this opportunity to share the presentation. Over to Mohan sir.
Thank you, Yogesh sir. We wholeheartedly welcome Mr. Milind Atrey, and I'll just quickly introduce. We will get introduced more through his sessions, but I'll just quickly introduce Mr. Milind Atrey. Atrey sir, good evening and most welcome on our platform.
Thank you.
Community of entrepreneurs. And when I saw your profile, it is awesome. I don't have words. It is speechless. It is mesmerizing. And no words can really express my happiness. Ek to sir, right from my last 20-30 years of journey, I have a high respect for teachers. So it is a very noble profession. On top of that, I have very, very high respect for doctors. You are doctor. On top of that, I have very high respect those who understand heat transfer. So, because 3rd year of engineering, Sukhatme sir ka ek book tha, itna difficult tha, sir. I'm sure you would be aware. The 3rd year engineering people, to get it through, they would be happy to get a condolence. There used to be a condolence kind of system. So heat transfer, and that too you are expert, and that too you have done a lot of research. Another important thing is, you had been in charge of sign, which is very, very closely related with us. So, probably I will not leave you. Even if you want to leave me, I will not leave you. So that is one. And the last few months or last few probably year or so, you have done a lot of research on oxygen, which is getting unfolded in the next 1 hour. So we all, I think, please welcome on the behalf of, with the claps, we welcome such a person who is having such a beautiful background, qualification, and everything. So welcome, sir. And I think you have been, you can have one presentation, and then we would love to have a question and answer session also, sir.
Sure, absolutely sure.
You can go ahead and have a presentation.
So thank you very much for having me here, and importantly, my classmate Uday is here, who was the person who got me here, and through Uday Lidbide, I am I'm here. So I thank Uday to introduce me to RISE. I was not aware of this organization, but whatever I heard, I found it mix of everything: spirituality plus technologies plus entrepreneurship plus women entrepreneurs, social entrepreneurship, and all that thing. Because I have been working in this area for quite some time. Of course, it's morely tech entrepreneurship, because of course we are limited to IIT Bombay as such. But importantly, I come with a background of almost 15 years of industry before I joined teaching. So after doing my PhD from IIT Bombay, I spent almost 10 to 12 years in industry of various places, and then came into teaching. So that makes a huge difference of having applied education in teaching also, which always helps. Your experience always helps in teaching also. And since last two and a half years, I'm the Dean R&D at IIT Bombay after sign headship for six and a half years. Last 2.5 years, I was in charge of the as a Dean R&D, wherein we see so many technologies being taken up by IIT Bombay and delivered to the user community, various industries. We make around 400 crores in terms of having research projects and consultancy work. And many of these are actually given to industry and ultimately are brought to the society. We don't talk big about ourselves because we believe our students and our entrepreneurs, alumni talk about IIT Bombay. But I can realize that before I became Dean R&D, I didn't know that we are doing so much of technology work which is directly being used by community, society as a whole. So with related to oxygen now, I'll put my slides also, but before that, I just want to a small preamble to that. I am specialized in cryogenic engineering, and as you know, we are talking about cryogenic engine, and I'm very closely associated with atomic energy and space. ISRO. Unfortunately, yesterday's mission failed. We couldn't accomplish our goal, but my major area is very low temperature, and I work below 1 Kelvin also. Oh. What you call as a dilution refrigerator and all that thing. So very high-tech area. I work on MRI systems, MRI machine, superconducting magnet. Oxygen happened to be an accident. Because of COVID, my laboratory has a liquid nitrogen plant, liquid helium plant, which we supply to the entire IIT. And where we used to liberate to atmosphere and continue with nitrogen from atmosphere air. We used to take nitrogen and liquefy nitrogen, which gets liquefied at -196 degrees centigrade. And we're actually leaving oxygen to atmosphere. But when the crisis began, suddenly we realized that we are letting oxygen go outside, but why not we do the reverse now? Let nitrogen go. Right now we don't require nitrogen, but why not collect oxygen? So we could showcase, we did that technology, demonstrated that with at IIT Bombay. And that had a big effect. Almost 1,000 people implemented in their nitrogen plant, because nitrogen plants are plenty. And that is why I'm going to talk about today about oxygen production. I got a lot of suggestions to Government of India, which I have made. I'm talking to Maharashtra government also, because we're expecting sometime third wave. But COVID is here to stay, and oxygen here will be here for for us to be ready with any supply of oxygen at any time. So I'll give my small presentation, not very tech heavy, but more on oxygen requirements for today and for future. The plan that I believe can possibly save us should we require oxygen in future. So shall I share my screen now with the PPTs I have?
Yes, you can.
Yes, you should, sir.
Yeah. Are my slides visible now?
Yes, yes.
Yeah. So my talk is going to be around COVID-19 and specifically the oxygen provision for hospital, because I visited various oxygen plants in various hospitals, and I was absolutely devastated to see the health of those, the way it's being handled, and an untrained person handling very high pressure gas and liquid oxygen. He doesn't know what that liquid is meant for and all those things. So I've come with some India's need solutions and strategies for futuristic game also. So is it okay if I take, how much time do you give? I take around 30 to 40 minutes, and we can have then question answer session, right? We can have discussion in fact, right? Is that okay with time? Yeah.
Sorry, but you free to speak the times that you have. Absolutely not a problem with that.
Okay, thank you. Thank you. So my presentation is going to be a small introduction, oxygen and need during COVID, oxygen production for medical usage, then the work we carried out, nitrogen to oxygen generated conversion for COVID usage, strategy for future, and of course, very importantly, the oxygen safety. So as everybody knows, and this doesn't require any big thing, but we can assume that the entire atmosphere what we have is basically made up of nitrogen and oxygen, forgetting all other gases, which are very small in proportion. So if I put around about say 79-21 kind of a percentage of nitrogen to oxygen, which is perfectly valid. So what is important is to know the percentage of oxygen in atmosphere. And what is also important to know how much liter per minute the gas goes and it is fed to the patient. Very important to understand how much LPM required, liter per minute requirement of oxygen should be for a given patient. Need not talk about this, but I'm always tempted to show the gravity. We don't realize many times what have we gone through, and I don't even dare to think about what has passed in the last year, I should say, in the first wave and the second wave. The second wave really caught us, the population of India, unaware. We were absolutely not ready. Nobody knew the gravity of such a situation. After the first wave, we have possibly come to a conclusion that, we are done with it. But suddenly second wave came and, everything went for a toss. The steady fall in the positive cases and low mortality rate gave a false sense of complacency of having overcome the disease. That is what happened in January to March, I should say. However, there are multiple spikes and deaths. The tragedy of epic proportion unfolded quickly and the situation rose to a super medical emergency. And I was right in the field during this medical emergency. The Maharashtra government, the government of India were calling me left and right to use, can the LPG cylinders be used for oxygen and things like that. We had come to a very blink level in stress to say that we had scarcity of everything, container, transport, devices, valves, of course, forgetting the technicians and trained manpower. That was absolutely not there and still it is not there. Just to remind you what happened during those days, if you remember what had happened, and people have stayed wherever they could, find a place, sleep wherever they wanted to, And it also made, the kind of accidents that we came across. Literally, there were at least 10 accidents happening in Maharashtra, and forget elsewhere. Maharashtra is supposedly a progressive state. But imagine what was happening at other places, including Bihar, Orissa, Uttar Pradesh was in a dire, absolutely very, very bad shape. And you can see what happened. And I can show a small example from Nasik. Everybody knows what happened in Nasik. So nobody knew what is inside this. Nobody had realized. A common man never knew. When I got a photograph having somebody smoking a small cigarette near this plant, and suddenly a blast happening down there, and he could never realize what had happened. Similarly, the connection that happened, because we used to have hardly 2 patients in 100 who possibly needed oxygen earlier. But suddenly, if 70% started needing oxygen in hospitals like this, we were never ready, we were never trained, we never knew what kind of infrastructure requirement is, and never knew what kind of psychology of the people. And hospitals are closed, air-conditioned rooms, ICUs. Therein, we never understood the importance of leakage, to understand leakage and understand the gravity of the situation. So the oxygen crisis, you can imagine that every person around us started lifting the, tank, oxygen cylinder, and people started, it reminded me of basically the day when you want to stand for a queue in a bus, for example, in Mumbai, or let's say milk queue or whatever, or rations. So standard oxygen requirement, if I come down to, is normally, let's say, around 500 LPM, liter per minute. One cylinder is around 7 meter cube that we normally see. And if I need to have 500 liter per minute, which is what can possibly cater to, let's say, 20 patients in a hospital, which will require me to have almost 1 ton per day oxygen, if I just talk. And if I don't have that oxygen fully, I need to have a 90 to 100 cylinders per day. If you go to any hospital, just walk in, they may have not more than 5 cylinders or 10 cylinders, which work for them basically because over a month or so. So we were never ready. But if at all we require 500 LPM, which was a very basic need of any hospital during these COVID days, that means they needed to be ready actually with 100 cylinders per day, we never had cylinders also. If I went ahead and talk about, let's say, 250 bed COVID medical setup for a hospital, which has possibly, if you talk about jumbo hospitals that had come, there where almost 1,000 people were accommodated, and assuming that out of 1,000 people, around 25% needed, means 250 people needed the oxygen, then we need to have almost 670 cylinders. We can imagine the requirements in those for any jumbo thing, and this was all over India, and almost 10,000 jumbo COVID medical setups were actually came into existence suddenly for a month or two, wherein 670 cylinders is absolutely understatement, I should say, and not more than 50. We couldn't had a jugaad one of 50 cylinders that time, and we have seen people. I mean, I was in the field, and we have seen people, couldn't breathe properly, and just waiting for somebody to offer some kind of a relief to them. If I come back to oxygen, pre-COVID days. So if I say pre-COVID, we had all the oxygen being used for industrial purposes, mostly for steel manufacturing, to cutting torches and fabrication. Then medical oxygen, of course, was used, but only 15% or 20% maximum. Medical oxygen application in multiple medical situations to improve oxygenation in tissues, assist breathing in patient, etc. And various estimates put the pre-COVID total oxygen usage at approximately 75 to 80% industrial usage, and 20 to 25% for medical usage. All right, so this is what we can say. Now, if I show you a figure which is in public domain, we can say that we had passed this curve and we are somewhere here right now. And just we are entering September range, and there are several predictions depending on which academician or which statistician we are talking about, but which epidemiologist also we are talking about. We're expecting to have a third wave somewhere around this magnitude, which possibly could be bigger than this, or as equivalent to this, or as smaller than this, or somebody said we have already started having a third wave now, and possibly we can have variants and multivariants and delta, gamma, lambda, whatever. Lambda has already shown up in Japan, and that is supposedly going to be much more infectious, or 4 to 5 times infectious than what we had earlier. So we should be absolutely ready. The only good thing is that the vaccination have started. Many of the people have taken 1 dose, but unless we take 2 doses, possibly we can't say that we are immune to the system. But therefore, it is felt that the impact will be less just because we have got vaccination. But mutation can take its own course, can show surprises, and we don't know whether we are going to be ready for that or not. However, from medical point of view, we have to be absolutely ready, absolutely on guard, and never should assume that we are anywhere here at all, basically. If I talk about oxygen production in India, so pre-COVID days and about the post-COVID days. In pre-COVID days, we got a 7,200 metric ton oxygen was produced per day, right? And that was completely used for various purposes, of which industrial usage was, core industry had around 2,500 tons and non-core industry had 1,790 metric ton, that kind of a thing. And therefore total industry was around 4,290. There was some medical usage, which was 1,210 metric ton. COVID usage was not there pre-COVID days. And total medical was around, let's say, 1,000 metric ton. So we had a plenty of stock waiting in the pre-COVID days. Almost 50,000 tons was sitting with us all the time. We don't have to worry, let's say, till April 1st. When the post-COVID started happening, right, we increased our capacity from to 3,300, also additional came. So we had a total capacity of 10,500 metric ton. The core area remained the same, but then we diverted industry, we reduced the industrial usage to 3,002 because something has to go on that thing. So we reduced our non-core industry and all that thing, and we diverted from COVID usage to almost 7,000 metric ton. We went to 7,000 metric ton. All the area of industrial thing was diverted towards the, but still we were shorting. What was plus here, we were falling short of almost 700 tons per day, which is a very, very thing. This was the data which was submitted to Delhi High Court. Now, what I discovered that if I talked to almost 10 technicians and I wanted to understand from them which one of these is oxygen cylinder. And out of 10, 9 couldn't identify oxygen cylinder. Well, every cylinder, every gas is supposed to be color coded. So this black and white is supposed to be oxygen. On the right side, what you see is oxygen coded. And even the wall that goes here has to be of a different kind, different materials, brass material. All right, so there are a lot of implications on using oxygen cylinder. All right, so this was absolutely unknown. Forget the fact that they couldn't even identify what was oxygen cylinder and all those things. So here I am telling you that the wall with the brass with a chrome plating and all that thing, which is normally not done, and the color code, the pressure is almost 150 bar to 250 bar and things like that. So product used in hospital was normally this. So we have got air separation units where we liquefy oxygen, where we take air from atmosphere and we liquefy air, and then air is separated in oxygen and nitrogen. And this is a major supplier to all the hospitals. So we basically liquefy oxygen, and this is a very, very big setup, very costly setup. It is all existing in steel industry as of now, because steel industry heavily use oxygen, and therefore they always have air separation unit. And they use oxygen to the best. I mean, interest. When I say industrial usage, is mostly the steel industries. But then whatever liquid oxygen is produced over here has to be transported. So liquid medical oxygen should be transported. And as you know, this oxygen gets liquefied at around minus 183 degrees centigrade or 90 Kelvin. My courses on cryogenics are available on NPTEL, should anybody be interested. And I teach for MTech students or BTech final students, Cryogenic Engineering 1 and Cryogenic Engineering 2, where I design this system for them, liquefaction system for them, the heat exchanger design, heat transfer design, all those things at a very low temperature is a very common exercise that students do. And these hospitals, this liquid is brought to the oxygen, to the hospitals, and it is vaporized then. It's converted to gas. The transport of oxygen never happens in gaseous stage because it's like a bomb. It always happens in liquid stage. And in this way, you can actually transport much more oxygen in liquid stage to any places, any hospital requirement. So any hospital possibly would have, a big hospital would have such a tank wherein liquid oxygen is stored. And whenever you want to use this, liquid is converted through a vaporizer and given to this. This was a very acceptable norm till now. But suddenly we found that most of the steel industries are on the eastern side of India and on the western side of India. For example, you can start from Tata Steel, then we got a Bokaro, then we got a Bhilai plant. Right, there are big plants, then you go down to Vizag, there are special steel plants. What we have on the western side is only JSW possibly, and maybe SR, one or two, but you know, Maharashtra, Gujarat, and all these people, we have no liquefaction facility down there. And all these oxygen then need to be brought from the eastern side of India to the western side of India, which was a disaster from transport and logistics point of view. In addition, therefore, suddenly we woke up to the fact that PSA plants could be used. But till now, the idea was that these oxygen is 99% pure, and therefore everybody thought it has to be 99% plus purity requirement. While you can see when we normally breathe air, which is 21% air only, and therefore there is no need of giving 99% purity. And suddenly we found that the PSA plant, that is the pressure swing adsorption plants, which generate not liquid oxygen, but gaseous oxygen only, and can give a purity of 90 plus. And suddenly government woke up and everybody all over India, WHO said that even 90% purity is good enough, which was always good enough, but it was never construed then that 90% purity is also good enough. And in small houses came oxygen concentrators. But PSA was a very big surprise, and suddenly we found that yes, this can save a lot of things, because many small or middle level hospitals had no possibility of storing liquid oxygen also, because there were no tanks. We hardly 2 or 3 companies in India make, Inox is one of them, for example, who make tanks, but they were mostly making such tanks only for ISRO, for example, never made so many tanks. And that too, the gravity of situation was so that they possibly will be required to make 50 tanks per day or something like that. Well, they could make only 1 or 2 tanks in a month. So they were not ready with the raw material, and of course the COVID time and things like that. So suddenly we could understand that in addition to this air separation unit oxygen production, liquid oxygen production. We possibly can have a gaseous oxygen also using PSA plant, using oxygen concentrator. So oxygen used in hospital, we had a liquid oxygen storage tank at the hospital premises. This is the most efficient system because you can store this oxygen, but don't forget that liquid oxygen remains in liquid state at minus 183 degrees centigrade, while outside temperature is 30 degrees centigrade. So we got a radiation heat transfer from 30 degrees centigrade to minus 183 degrees centigrade. And every day in 24 hours, 2% oxygen gets boiled off. So if I have about 100 liters today, tomorrow when I come back, I will have 98 liters, next day only 95, following day 90 liters. So even if you don't use, the oxygen is getting evaporated all the time because radiation heat transfer is happening from atmosphere to minus 183 degrees centigrade. The smaller hospitals or medical centers do not have liquid oxygen storage tank facility, and they suddenly started to need oxygen cylinders. So they started banking on oxygen cylinders. Now, oxygen cylinders are at 150 bar. The problem associated with this was substantial wastage of oxygen started happening. Each cylinder loses around 5 to 10% due to lack of pressure in the cylinders. There were leakages, a lack of adequate cylinder manufacturing capacity to cope up with demand and demand explosion suddenly. So oxygen generation can be generated from atmosphere air by cryogenic separation of, commercially I will say, cryogenic separation of gas, where you get 99% purity. And you can see such a big tank coming in Bokaro, where in such a big distillation column is there. And this is a huge infrastructure costing more than 1,000 crores, right? So it cannot come in a year's time. It takes almost 3 to 4 years to have such a facility installed in one place and things like that. The second possibility was direct supply of cylinders using pressure swing adsorption unit, where we get 90% plus purity. So this is what we started looking at seriously. And third one was oxygen concentrator, also uses a small miniaturized PSA unit, where you can get 90% plus purity in this case. If I talk about now the first aspect of cryogenic separation, so this is air input is there. You get an air compressed to let's say around 150 bar. Then you got a heat exchangers, and you got a distillation column where nitrogen and oxygen. The nitrogen boiling point is minus 196 degrees centigrade or 77 Kelvin, and oxygen boiling point is around minus 183 degrees centigrade at 90 Kelvin. So depending on the high boiling point comes down and low boiling point goes up. So nitrogen comes from the top because it's a vapor form, oxygen gets liquefied and comes from the bottom. And this distillation column can be as big as 50-meter height or 100-meter height also, depending on the purity requirement that you have. So you can see these plants where Linde is a big company. Linde and Air Liquide have got huge presence in India, and Praxair is the American company, have got a huge presence in India. In India, in Maharashtra, we have got mostly Linde, and elsewhere you can find Air Liquide, which is a French company. This is a German company. And so you can find such units. At the same time, you've got a tankers, which now will get filled up over here, and they will travel, let's say, for 7 or 8 hours. But then if they start carrying 1,000 liters from here, they will have a boil off happening over a period of time because they are traveling on Indian road conditions also. You have to understand these facts. So Linde opened second air separation plant at Tata, still talking about 1,400 tons per day production. I can talk about a small schematic you can find, and these tanks, as I said, it's 1,000, it could be a 50 to 100 meter, and all these things having nitrogen going up and oxygen coming down. A lot of dynamics of heat transfer and mass transfer happening in this. I will not talk about that, but just a small glimpse of what is happening in this tall unit. There's the condenser on the top and there's the evaporator on the bottom, condenser or boiler, that is what we call it as. And on this, we got a trays where the heat transfer between the liquid coming down and vapor going up happens. This is a very, very tricky chemical engineering and mechanical engineering coming into this, and heat transfer happening down there, which is one of the exercise for the MTech student, that they calculate number of trays required and all that thing, and will not go in the details of those things. But it's not a very simple thing to come down immediately and to do that thing even in a year's time. It requires 2 years, 3 years to install, and basically have, this is just small part, but there are compressors and chiller, refrigeration unit, purity requirement, heat exchangers, and all those things will come into picture. Importantly, then we got to carry this liquid oxygen. And if you remember, we got an oxygen train that came into existence, which was running from eastern coast to the western coast. We brought oxygen from Bhilai steel plant to Maharashtra, or Tata Steel or Bokhara steel plant to Nagpur, and then from Nagpur to Mumbai, and all those things happened thanks to the idea that came on with oxygen train, and all these tankers were sitting on them. They got filled up. The moment they touched the cities, they started, taking these big tankers, which were actually could be utilized possibly only over 1 or 2 hospitals. So on one go, we can possibly have 15 tankers like that. But we had a tankers number also less. So it's a small tanker around 1,000 liters for 1 hospitals, which they were consuming right in 1 day, basically. And usually liquid container natural loss is around 2% per day. And you can see when I'm transporting liquid oxygen from this container to this big hospital level, you can see how much boil off is happening. So around a 10% or 18% boil off does happen when you decant liquid oxygen from these tankers to such a tanker also. So because at the same time it sees the 30 degrees centigrade ambient temperature outside, and therefore it gets boiled off, which is a loss which is known. The same loss will be there in transportation from source to destination, while 30% flash loss, that means conversion of liquid to vapor, happens while transferring from main container to small container. So you can see this boil off is happening basically. And therefore these tankers are heavily cryogenically designed. They got a vacuum insulation and things like that, but still you can't prevent the heat transfer by radiation happening from outside to inside. So cryogenic air separation unit have advantages because of the density of liquid that they carry a lot of oxygen. Therefore, and if you talk about the consumption per unit production is pretty less because they are produced in bulk. Therefore, you've got a high purity also, and ability to produce liquid at the site is very, very high, of course. The disadvantage is very high capex, very high capital cost, large scale utility requirement, and huge space requirement, safety requirement, and all those things. More space required for installation, and long time startup and shutdown. So when we want to start the plant, you will get the liquid production maybe 3 days later or something like that. Even shutdown is sequential and it also takes a lot of time. So it's not a sudden process. Just start a button and you start having oxygen immediately. No, it is not like that. So it is a planned operation. It's a breakdown. Some maintenance schedules also are planned, and therefore we can't take it for granted. This was the first cryogenic separation, cryogenic oxygen liquefaction. If I now take you to the pressure swing adsorption, wherein the swing of pressure happens. So I will tell you how that happens. So this is a PSA unit, and again you got a screw compressor where the air is compressed, and this compressed air gets the moisture is removed and other oil particles and everything is a dryer, refrigeration dryer unit, activated carbon. Basically, the moisture will be removed. I'm storing air here around, let's say, 8 bar. And this is what is called as a PSA unit, wherein you get a swing. So, and I'll talk about that later. And from here, you can get nitrogen or oxygen, whatever you want to. I'm showing right now a picture of nitrogen adsorber. So this is a PSA unit where we want to play with, and that is because most of the other things are standard, but of course it also costs a lot. Screw compressor also costs lots. You have to understand all these things are going to be storage devices, but the moving component is going to be only compressor, right? So this PSA unit, pressure swing adsorption, if I got a unit which is air is coming from this side, so this unit has got adsorbent here. And this adsorbent, just imagine like a filter that it will adsorb one gas A out of gas A plus B, and it will let only B pass through it. So gas A will get adsorbed here for some time, and B will come down here. When now this gets saturated with gas A here, right? A reverse blow comes and this A is blown to the atmosphere. So when gas A travels for some time, gas B will come here, gas A is getting adsorbed here. After some time this gets saturated, then we start using this cylinder through which the gas will travel, and every time this will get, the B is going to be getting transported here. And when this guy is, the gas B is going through this will get regenerated. That means whatever I absorb here is let go to the atmosphere. So there's a generation time and there's a regeneration time, and such a PSA unit works. So one time this works. So this is a one swing that is given, and other time the reverse swing is given to blow it to the atmosphere here. Similarly, that means when nitrogen plus oxygen is going on here, we will absorb nitrogen and only oxygen will go through this. This is on a molecular sieve level that we're talking about. When this gets saturated with nitrogen, we will leave this nitrogen to atmosphere. And during this time, during this regeneration time, the other cylinder will come into picture and it will let only oxygen to pass through it. Right? So for a minute, this will work, for other minute, this will work, and this will go in a swing-wise way. A simple mechanism, but you have to adjust with the flow rate, the diameter, the height, the time, all it. So all these are very important parameters, and all these valve will open automatically. So you can actually make a program. This valve will first use while other valve will be closed, and this valve will be open. While when this is happening, other valve will come into action. So the valve opening, the flow rates, the height of the PSA unit, the adsorbent stacking, and all these things are very important. But once you understand this, you can optimize all these parameters very well. So this was here the compressed air sent to the adsorption chamber. One tower in generation mode, while the other tower will be in a regeneration mode. The separation of gases. So for nitrogen, normally the adsorbents are used are carbon molecular sieves, and for oxygen it should be zeolite molecular sieves. So this is the adsorbent requirement that we should fix in those things. Now, problem is during COVID time, this zeolite molecular sieves, what we want for oxygen, suddenly went out of market because everybody started making having zeolite, and it went. There's a lot of Chinese zeolite in the market which cannot give the performance because it is always the cost. So companies like BASF and Armia and all that, there are good companies, German companies, Swedish companies. They give good, but they're very costly, and of course it takes time. While Chinese companies are there, which can give as small as 100 units per kg or something like that, but they are of course are not going to be dependable, not going to be persistent in performance and things like that. So a lot of people actually made a lot of money in this period by giving zeolite mixed proportion, impure, and all that thing. Automatic switching of generation and regeneration enables continuous supply. So whatever it happens over here, switching will happen over here, but from this side you will get continuous flow of the gas. For the inlet side, you will get continuous inlet of air at 8 bar around. Okay, so we'll get 8 bar air, and the air will come at, oxygen will come at around, let's say 3 to 4 bar at this point, which can actually be given to the directly given, and this will come out a purity of around 90 to 95. So advantage of PSA units are we got complete automation and absolutely simple operation. No man attendance is required during operation. Enhanced failure safety and reliability, quick start. And so here is a button start, literally button start, that within 15 minutes oxygen production can actually get started. Moderate dimensions and lightweight, low noise levels, extended operational life, low operating cost, easy installation and integration into thing. And most important, they are all skid mounted. So they can actually be transported in truck from place A to place B within no time. So it's very important that this is not like liquid oxygen where a plant is situated somewhere 300 kilometers away from the hospital. You have to go get a liquid oxygen, come by road, which almost take 10 hours, and then decant that oxygen in a, if you got a storage capacity. But here, these are the plants which can actually be, just by put it in truck and erect it whenever you want, wherever you want, within 15 minutes, the operation can get started. So this was the biggest advantage we found, that these plants can be really transported from place A to place B. And the disadvantage or drawbacks, I can say possibly low oxygen purity, but which is perfectly acceptable in this period. Limited capacity, maintenance required. That means compressor oil has to be checked, but maybe yearly checked. It's not a big problem. Compressor is a pretty mature technology these days. So the advantage of PSA unit was, there are plenty, and I will not go. I'll just talk about all those things, right? And go ahead on this. If I were to compare, and this is what is a lot of doctors ask, because I gave this talk to a lot of doctors and hospitals. So the capital cost for PSA plant is one-time requirement, but payback period could be within a year's time. Liquid oxygen, nobody does, because liquid oxygen you just buy from outside. So you just have to have a container down there and just buy oxygen. You don't have to worry about how it is produced, but now this will be produced right in your hospital here. The recurring cost is only electricity. Here we have, of course, our rent. Safety, this is safe. This is of risk of uncontrolled leakage. So liquid oxygen is being at -183 degrees centigrade. One has to understand the effect at low temperature. One has to understand the effect of maintenance and all those things. Space is absolutely less footprint. The higher footprint, operation is absolutely easy. Cryogenic plants, one needs specialists. Here also, when I say easy, we need a trained technician also, but this is not a one-man operation. A team of people work who are trained in mechanical, cryogenic engineering and chemical engineering and things like that. Convenience is one-time installation and 10-year life. Of course, here is all the time tanker movement will going to happen and space movement. Evaporation loss, none, because we are not dealing with liquid here, but here the evaporation loss are plenty. And the costing, if I didn't get the cost because, you know, the cost of oxygen during this period was so artificially inflated that I would really not got the real cost. However, liquid oxygen cost is around 750 to 2,500 per liter per kiloliter, $10 to $30. That is pretty known because, but that of course that also went up because of the scarcity and emergency operation that we wanted. So there are some details of some plants which cost, big plants which cost. So the costing can happen from, let's say, 45 to 50 lakhs to 2 crore, depending on how much LPM and all that thing you want. The third category we found, I think I have taken around 30 minutes here. So third category I found is oxygen concentrator, which basically,
no issues.
Yeah. So third category. So first category was the cryogenic air separation unit that we talked about. The second was a PSA plant, and third, which also got a lot of importance during this the last 6 months, is a miniaturized PSA plant, literally, and it's called what is called an oxygen concentrator, which can be used for a family or at home or a person or even small hospitals. And in IIT Bombay Hospital also we had one air concentrators, which is also now I have made in our laboratory. But it uses the same PSA technology, but miniaturized version. There is a small compressor, it's air pre-cooled, sent to separation unit, again filled with. So you can see the same kind of a pre-cooling, same kind of a arrangement of a PSA unit down here. But this can be possibly lifted, if not with hand, but by 2 persons from one place or one room to another room also. So oxygen stored in tank at constant pressure for constant supply. And for mild to moderately symptomatic COVID patient, see, normal COVID patient would require, let's say, 5 to 10 LPM. Okay, but person in ICU may require, let's say, 20 LPM kind of a thing, and person in operation theater may require around 25 to 30 or whatever. I'm not a doctor, so I will not be able to tell exact, but normal 5 to 10 LPM is what 60% or 70% of the patients would need. Okay, 20 liter per minute will be required for the patients sitting in ICU. So such units came into, and suddenly these units came and a lot of countries donated a lot of units. A lot of Chinese products were there and costs started varying from 50,000 to 1 lakh. According to me, when I make it lab, it should not cost more than, let's say, 10,000 rupees or something like that. But again, the cost got inflated during this emergency time. And a lot of people made a lot of money and nobody bothered about, because the buyers were in such a frenzy that they never bothered about purity requirements, availability, understanding technology of this thing. But of course, everybody was almost, going from no end to other end, basically. So wherever they found that something is there, people started worrying about that. So during this time, we came up with an idea of the nitrogen plants are plenty number in India. And I just talked to you about the operation of a PSA plant. And there are several nitrogen plants in India, and they're all using fertilizers, urea, food industries, heavy conductor industry, electronics. So I got a rough feeling that there are almost 1,000 nitrogen plants in India. And all these plants come under central government, state government, utilized for fertilizers, and very, very high-end plants. So most of these plants use PSA units. And as I said, it has got a filter substance. So thus conversion of existing PSA nitrogen to PSA oxygen plant was suddenly we found a good alternative. In my laboratory, we got a PSA unit, and we thought, and I got one of the IIT Bombay alum, Mr. Raj, belonging to Spantech company. He showed interest, and I got Tata, because I thought if we could do that thing and we have to go all over India, I need a person like Tata's who can do this with talking to government. I, being a teacher, I cannot, my reach is not, and I can show a demonstration, technology demonstration, but I cannot go beyond that thing or beyond level. But we were in such a dire need, and this was around somewhere around April end, and we were, people were dying in front of eyes, and accidents were happening. So we thought that by change of adsorbent material in this tower and wall timing change, PSA nitrogen plant can be converted to PSA oxygen plant, and that can happen literally within a week's time. In fact, We wanted to do in 3 days, work 24 hours a day and not a problem, but we can do all that thing. But that means that we remove the adsorbent material from this and put up next material, correct material into this, in both these tanks, play with these valves, play the electronics associated with this, change the oxygen purity meter, play with some additional pipes that we have. But arrangement before this, all the compressors and all that remain the same. So chunk remain the same, the PSA unit has to be changed. And if we could do that thing and showcase that, I'm sure the entire India can possibly demonstrate, do that thing. So for which we thought we can do a demonstration unit. So for which what is to be required to be done is change CMS to ZMS, that is carbon molecular sieves to zeolite molecular sieve, which is a very important change. So carbon molecular sieves are carbonaceous materials and have very narrow micro. I'm not expert in adsorbent material, but there are a lot of adsorbent chemistry people, chemical engineering people sit here, which has got a pore size of 3 to 5 angstrom. This is a molecular. So these look like that basically. So naturally charcoal kind of a look. And you've got a zeolite molecular sieves, which is an alkali metal, aluminosilicates, is a sodium form of type X crystal, that is, and it adsorbed molecule with effective. So this will adsorb nitrogen and this will adsorb oxygen. If nitrogen get adsorbed on this, we get oxygen through this. Oxygen will pass through this without getting adsorbed. While here, oxygen will get adsorbed and nitrogen will pass through this. And this looks like this. What is most important is to make this, and because this is subjected to high pressure, they should not become powdered. They are sintered and compacted, and they should have a good pore size. They have a uniform pore size. And Chinese material had all kinds of forms, all kind of powder form. But a BASF one or whatever form I had seen, they were very costly, but they were regular size, nicely compact. And once you fill in that thing, that can stand for 5 years, that kind of a thing. And there are now lithium based also coming. This was sodium based. The lithium based also shows a significant enhancement in the adsorbent capacity, maybe 6 or 7 times more. So you can still make it compact and have more flow rate and more oxygen production can happen. So this conversion, we thought 1 meter cube of oxygen produces around 30 to 35 liters. It requires around 30 to 35 liters zeolite. So we have to change following thing in existing nitrogen plant. Change the oxygen filter, that means make it with zeolite, remove the carbon filters, have the oxygen filter, oxygen analyzer, because purity was very important. We have some piping changes, some diameter changes, pressure control valve to be provided to oxygen to a control pressure, and of course change CMS to zeolite. This operation we thought, we came with a diagram that how much time each operation should take and started giving information to all the people. So we showed this demonstration in our institute here and converted a nitrogen to oxygen plant, because my lab has all this facility. And we showed that at 15 LPM, if we convert one plant around 417 LPM, so for example, if I take a 25 meter cube per hour plant, it can give 417 liter per minute, and it can support around 30 patients in hospital. So you can see that it is sitting on a track which can be transported, skid mounted stuff, and can be transported. We did a lot of, I will not go into the technology of this, we did a lot of trials at IIT Bombay, and to see that this consistency of purity over a period of time was seen. So you can see that we had a skid mounted PSA plants. This is our director, and we could showcase these units. Can be just put in a 3-4 people can put this in a truck and can transport within 2 hours. You can actually take it to various units. So here are some nitrogen, we got converted nitrogen to oxygen at various places. And a lot of people came forward when the news got into action. This is a Karnataka hospital. This is a Mumbai Chembur hospital here. And this impact, when we show, we got Tata Consulting Engineers, Stantec, this CPCB, Central Pollution Control Board, because all the nitrogen plants under fertilizers and all that are under CPCB, central government, this thing. And we went, I mean, these Tatas could do this job very fast. They could once they understand the technology, they got in touch with the central government ministry. In fact, 2-3 ministers called me personally to understand this. And then we could showcase that more than 100 and now almost 200 plants are given for conversion. That could happen immediately. So this conversion, because we had so many plants available, only then we wanted to have plants in running condition. It's not that we want to corrosion plants and all that, we wanted running. So almost we could convert 100 to 200 plants, and more than 10,000 people could get benefit of this. the plants can go back. So because we had ordered many plants, but still those plants have not come. With DRDO and Zeolite and coming from Germany and other places, the plants are being now installed now. But this is, I'm talking about now June and July. Awareness suddenly went up, and in fact, we were surrounded by calls from various people, and especially from various IITians who have become IAS officers. They certainly started calling and tried to understand this and implement it in their own places. And I could talk to them about technology, but I should give credits to some of the ministers in central government who personally called me and tried to understand. One of them is Mr. Shekhawat, Jalanirmiti minister, who called, who understood, who asked me very relevant question. And he was the first person who actually converted a Jodhpur or Jaipur nitrogen plant to oxygen and started using it also. So this is, yeah, you can see nitrogen से oxygen में परिवर्तित पहला plant that happened. Kendriya Jal Shakti Mantri Shekhawat ke se. He's quoted me that he talked with me, and we had a lot of publicity on this, and it made a huge effort, and it could sort out the immediate plants, immediate requirement at that time. Now, I've talked till now about in what way oxygen can be produced, the cryogenic way, the PSA way, and the concentrator way. And we also talked about nitrogen to oxygen conversion also that can be done. The strategy for future. If I got 1,000 oxygen plants in India today, we don't require that much of oxygen. And these plants we are importing, we are spending a lot of money, foreign exchange and all these things. According to me, this plant will just stay here right now if we don't have a requirement. And should there be a requirement? A requirement will be for 2 months, but these plants are going to be a permanent feature here. They will get corroded, they will not work. And that's why I've got a strategy here, which I'm running past to a lot of ministers also. So every liquid oxygen plant, we should compel them to keep, Government of India or every state government should keep a 50,000 liter storage vessel in every steel industry. And this is our vessel, this is government's vessel. And the steel industry should produce 50,000 liter and keep it for emergency purpose. Of course, they should use it. But should there be need this 50,000 liter belongs to the industry, belong to the government. So each one should get provision, and this should be always storage maintained by the steel industry. That was one suggestion. They can use this normal usage of LOX, liquid oxygen, as normal usage till the urgency. The moment I know the urgency, my 50,000 liter for every state, every steel plant should be maintained for government itself. And every district should have oxygen PSA plant about 500 nm³ capacity. We can support 500 people. And from there, we can actually fill in the cylinder. So the cylinders cannot be transported for a long distance. So every city, for example, in Pune, at 2 or 3 places, we should have such PSA plants from where cylinders can be filled, all right, at 150 bar. And the cylinder can be transported to an area about 10 kilometers around to every hospitals. And these plants can work continuously. We should have a team of technicians trained. And I'm coming with the next program now to train the technicians and the engineers to handle such plants and understand the oxygen usage and oxygen leakage and all those things also. And the proposal to convert all the nitrogen plant to oxygen within no time, that training has to be given, and all the nitrogen plant listing and all those things. Because in Maharashtra only we got around 150 nitrogen plants when I made the list of these plants list. The proposal of conversion is given. So I made a new proposal here that the left side infrastructure is available everywhere. Compressor, purification, air vessel, and filter is optional. Can I have 2 PSA plants without, if I don't want to even convert that, wherein because nitrogen is commercially used all the time. Nitrogen gas is commercially used all the time. So this plant can work. Whenever I want to use nitrogen, just connect it nitrogen way. So let this valve be closed and this valve be opened, and let us have a PSA nitrogen in action, and it is producing all the time nitrogen. While this red thing is always closed. And should there be need, I just close this and start oxygen. So this is a one way of having oxygen availability anytime. At the same time, this infrastructure will be used all the time because compressors and all these things should be used all the time. So this is a proposal which I have given, that let the people, why should people just keep the plant? But they should use that at least for nitrogen production, which is a commercial entity, which this gas can be sold, and in food industry and fertilizers, this is needed all the time. But this is a provision that they can do, and possibly we can compel that every nitrogen manufacturer should have such a PSA unit sitting down here. Or else, of course, we can come, then should there be need, we can convert this to nitrogen to oxygen also. But I believe that we can have one alternate PSA sitting down there, which could be tested once in 15 days so that it is always in rolling condition. But should there be need, we can all play with this wall timings and produce oxygen accordingly. So this is a suggestion I have given, and let's see this goes to the right ears and possibly to be affected. I come to the last 5-minute part now. Oxygen handling is a very important that everybody understand oxygen, and I've literally talked to a lot of people on this, but nobody understand the role of fuel and ignition source and oxygen. The fuel and ignition source is not a very big thing, but should air be coming, that means oxygen coming in contact, this contact should never happen. One should understand the importance of this triangle, that this oxygen part should always be kept away from fuel and an ignition source. Because this we do in our lab, and I've seen that so much importance here. Oxygen is a good oxidizer, and everybody knows that atmosphere is sufficient enough. Oxygen enriched environment can increase in various hazards. It can increase the corrosion rate very, very fast. Fire and explosion risk get multiplied 10 times, and incombustible material can easily burn and ignite. It increases the flame. It also affects the flammable range. Energy required to ignite is very, very small. You have to just give a small spark, and that's it. You have it. Very important that small greasing hands, this can also ignite basically. So you should never handle such things, such tools which are incompetently various ways. People don't bother about this. So avoid any fuel sources like fuel vapors, greases, etc. They should never come in contact with oxygen. Use material which has got high ignition temperature and non-reactive to oxygen. Ensure the hoses are leak proof. So the carry, suppose hoses are used, they can possibly have some other gas. Leakages can cause escaping high velocity oxygen to initiate fire explosions when enough ignition sources are available. And we have to actually flush the hose and lines before pressurizing to remove them. So we have to remove all these hoses from air, moisture, all these impurities before we start using it for oxygen. Otherwise it can cause fire. So maintain proper ventilation. These are all important things everybody knows on paper, but very few people implement in practice. And liquid oxygen, of course, is a cryogenic fluid. We got cold burns. Exposure to liquid oxygen can cause severe cold burns. Even exposure to liquid oxygen to materials. See, material gets shrunk at low temperature. Walls, O-rings, ceiling materials, everything is subject to, they have different characteristics at low temperature. I will not go in the details like that right now. The last is a little, what has this taught us, all of us, how world has changed during COVID. We are all working from home. We got a renewed gratitude for essential workers. We are all remote learning, no college experience, and I feel very bad for our students who have never seen school, never seen IIT, but possibly our MTech student may graduate sitting at home only. Will never experience to come and see what is hostel life. Of course, we have learned renewed relationship with nature. There have been huge mental crisis right now, and I'm sure next 5 years are going to be real problem to a lot of young students, as well as the older generation, and as well as the working professionals also. We should be ready for the next pandemic. The healthcare infrastructure needs to be prepared for crisis of this level. So quintessentially, we should be taking care of all these things. It is evident that resources, funding tend to reduce as the outbreak happens. You see, the politics, entire politics course also has changed because of pandemic suddenly. Effective leadership is very important. Better understanding between countries required to share scientific research knowledge has become very important. Increasing the resilience of health systems and universal healthcare policies and all are very important. I'll thank you all very much. I hope I could give some impressions of what we all went through during the last year or so. I hope we don't have to experience that at all in the coming days. But thank you for patiently hearing my talk here. Thank you very much.
Wonderful, sir. This is amazing. Your work is really, it deserves a big salute. It deserves applause. It deserves whatnot.
Thank you.
Yeah, and you are saying 10,000 people and more who must have been benefited. Yeah. Moreover, the people have understood that something like this can be invented. That that kind of If somebody is running in less than 4 minutes a mile, then, he has opened a new horizon that the others also can do. So,
literally.
Yeah. So it is really, you deserve a big salute, and you are no less than any
Oh, thank you.
soldier.
No, I'm a teacher. I'm happy to be a teacher only. I don't need any other adjectives, please.
That you have been humble, so that's good about you. So PSA nitrogen to PSA oxygen, that conversion is also wonderful. That you are talking about maybe less than 3-4 days or something like that.
Yeah.
It's really amazing, really amazing. And I think Mr. Srinivas is having some questions. Srinivas, you can go ahead and ask.
Yeah, good evening, sir. It was amazing to hear you out. And I was just wondering the geolite thing that we put on these PSA tanks. Do they last for 10 years or we need to replenish?
5 years is a good time that they last, and after 5 years we have to see damage. Otherwise, we have to change after 5 years.
Okay. And the way I understood, like many of our industries also have these compressors, and we use a lot of compressed air. And
Air compressor is not a big technology. Air compressors are known, but unfortunately, those compressors of these screw compressors are not made in India. We are importing still the screw compressors.
Okay.
Milind sir, the suggestion which you have given for the steel industry is really wonderful. Is that getting implemented?
Yeah, so see, I can't directly reach out to the steel industry, but I'm going through the ministers here.
Agreed.
So I put my thoughts to them, and it is they who should decide and dictate. I can take care of the technological aspect to convince the thing, but what I say is government should buy the storage device and keep it there.
True. No, that's a beautiful suggestion. That will create, the
reserves.
Yeah, exactly. That's a wonderful suggestion. Yeah. Anybody else is having any technical questions on this oxygen case? Anybody else who's having? I have few other questions other than this, sir. If anybody else is having other questions. I have few more questions, sir, because you are ex-sign also.
Yeah.
So can I ask you something on that?
Absolutely. Anything on IIT Bombay, anything you want to ask me, sign, so many things.
See, the overall, as initially presented by Dr. Yogesh, who is the founder of our bureau. So, we try to help our community. Now, I have been working in the as a teacher also since last 20 years as an honorary to a lot of engineering colleges and speaking on entrepreneurship.
Right.
So the one thought which came, and fortunately by the grace of God, we are in cooling towers, sir. This is a heat exchanger. So I am associated with a lot of corporates in the country.
Mm-hmm.
So I have been talking, forget my personal business, but I have been pushing it the industry institute relations.
Yep.
Yeah, so that is where probably we will take your help.
Evaporative cooling is all required everywhere right now. You're all talking about evaporative cooling, which is what happens in cooling towers, right?
Correct. No, we would love to take your help. As an IIT or as a sign, because we are all MSMEs from 5 crore to 100 crore, 200 crore. We always need some help on the engineering, innovation, research, and this and that. How IIT or sign can help us?
So if you want a problem from research, if you feel that there's some consulting required, you can write a mail to me as Dean R&D office.
Wonderful.
I can put you across to the right professor who can work for you for 3 months to 6 months to sort out your problem.
Wonderful.
Sign is basically for startups. So if you got a new technology and you want to, get incubated, or somebody want to get incubated in sign, of course it comes with seed grant and everything. And it can put you with the right mentors and the market and all that thing. I don't think you require that thing. But if you want somebody to work for you in terms of development of a technology, that idea you have or a problem you have, we can always have a professor who can do consulting work with you or a project work with you. So I've been working with a lot of industries right now to help them come up with new ideas, new technologies. I work to develop cryo refrigerators to give 50 Kelvin in my laboratory, which can be used for various purposes. Unfortunately, it has not commercial usages, but it has got in fact, for vaccine, we are working very closely also, vaccine transport and all that thing, because Pfizer vaccine was to be transported at minus 80 degrees centigrade. So we didn't have this technology, and that's why we went with the Covishield, which is to be maintained at 5 degrees centigrade only. But low temperature transport is a very big topic. For example, we don't have a refrigerated trucks today in India so much for carrying ice creams at minus 30 degrees centigrade. These are very important topics. So TRU, what we call as transport refrigeration units, is a very important need to transport vegetables from village to the city, or transport item that has to be preserved during transport, especially the milk items and refrigerated items like as I said, ice creams and all that thing. We are bound by hours. We can travel only for 1 or 2 hours, but we can't transport it to Hyderabad, for example, from Maharashtra, because we don't have that kind of TRU setup, transport refrigeration unit. It's a huge area where we lack. And they're all, we all should work towards these things together.
I agree. Suppose, people like me, if I want to, I want IIT's help for...
absolutely. I mean, you have to pump in money. Somebody has to fund such research, and somebody has to...
That is true. So
I mean, we have been doing work with various industries. We have been doing work with various industries on various topics.
For MSMEs also, IITs...
MSMEs. I mean, we don't differentiate between startup, MSMEs, big industries, all are same.
Okay.
It has to have some research element so that the professor gets more interested. That's the only thing.
So, for example, the heat exchangers we are talking about, let's say we talked about evaporative heat exchangers.
Oh yeah.
So for cross flow, counter flow, can IIT help me in
Absolutely. There are a lot of professors who are working on heat exchangers. So absolutely, you just send me a problem and I can find out a right person for you who can help you to design, manufacture, test, whatever.
Wonderful. Great. I mean, wonderful. I really enjoyed every minute of this session. Yeah. Anybody else who would like to ask any questions?
Anybody can comment on. I mean, not that everybody may have understood, but at least the oxygen requirement in the time today and future is going to be very critical, very important. But anybody has any comment, I would like to hear from any of them. Marathi पण बोललं चालेल, काही problem नाही.
Correct. कोणाची काय आनंद तुझी काय comment?
No, it's a wonderful session, sir. We are, as a group, we are very much impressed, and so closely we could hear all the...
Anand, आवाज ब्रेक होता आनंद. आनंद तुमचा आवाज ब्रेक झाला.
Which, in difficult time, really you have helped the society.
Thank you.
Yeah. I think
I have one question.
I think there is a problem with communication.
And now it is okay, Anand. Yeah, Gopal, you have some question.
Yeah, I have a question.
No, it is a very good thing, and I must thank you to have you with us for this evening.
Thank you.
Gopal, go ahead.
Yes. I was having one question. During the second wave, when the oxygen shortage and all were there, the government allowed us to use industrial oxygen for medical purpose. But because of that, the post-COVID problems which came to the patients who gone through the COVID situation, after the COVID, some other diseases come out.
Hey, but that if you are talking about mucormycosis and all that, that has not to do with that thing. See, oxygen cannot be going directly in the thing, right? It has to be hydrated.
Okay.
So whenever oxygen goes, it's a dry gas. So when it goes inside, your skin here can actually be subject to a lot of dryness. So normally when you see oxygen goes in your throat, it needs to be hydrated with water. Right. So that was, a lot of people were so eager to do all kinds of processes to themselves that they let the oxygen go dry directly, but without hydration also. But not because of industrial oxygen given to, because as long as the purity is above 90%, WHO has allowed to go for that thing. Of course, the cylinder filling, cleaning mechanism, purging mechanism, all these things have to be, there are norms to follow those filling operations, I think, which was done. But many places I understood that the hydration had not happened. Oxygen while entering your throat and with nose, it needs to be hydrated with water.
Okay.
Then it keeps your, it will not dry your skin. Otherwise, you will have other mucus problem and all those things, which happen. Yeah.
Wonderful, wonderful. So anybody else? Otherwise, we'll declare that this event is closed. So nice of you, sir. I again wholeheartedly give a lot of thanks to you. Thanks
Thank
for
you very much.
your time. And
I think
thanks
Uday is asking question. Raise the
Yeah.
hand here.
I have one question, Milind.
Please,
Oh,
please.
Yeah.
Please.
See, you are talking about the mobile plant.
Yeah.
PSA mobile, right?
Yep. Yep.
Now what we are looking for is that the existing nitrogen plants can be converted, easily converted. But if you want to reach over to Taluka and even to the remote places, such plants are not very closely located, right? So
Right.
even now, what I have seen is that on the petrol pumps also we fill nitrogen in our four-way, right? Can that plant be also converted into?
Yeah. See, you have to understand that they are basically nitrogen plants. So they take air, and air has 80% nitrogen, let's say broadly. That means nitrogen has a huge percentage. But the moment you convert it to nitrogen to oxygen, now air has only 20% oxygen, right? So plant capacity comes down drastically when you convert nitrogen plant to oxygen plants. So if you talk about petrol pump plant, that is a very small plant. Now you can imagine that conversion, if you do the oxygen LPM that you get is going to be very small, minuscule. So it may not be worth doing that conversion. Of course, you will get oxygen, not a problem, but that may not be worth it. And that's why we went above 100 nm cube only straight away. So we selected such plants which has got very high capacity of nitrogen. And then 1/4 of that, what we get is actual practice for oxygen. Okay, so that's why we rejected all small plants, which are basically the petrol pump plants of nitrogen, which are very, very small proportion of oxygen.
Miniature, huh?
Very miniaturous.
Okay.
So what happened, in fact, I told the minister also that if you got a huge, big nitrogen plant, all these jumbo COVID setups can come near the plant straight away instead of shifting the plant now, because that's a huge plant now. All right. And the middle level plant can actually be shifted to oxygen, shifted to hospital straight away. And that is what he accepted, that the big plants around the big plant, they had a jumbo COVID setups came there around the same plant, and the middle level plants could be shifted to hospitals in the villages also.
And secondly, these oxygen cylinders, you said there's scarcity, the manufacturing time and everything.
Yeah, that was that's why these plants don't require oxygen cylinders now. They are directly fed to the pipeline.
Okay.
So the PSA plants now, the oxygen which comes out at around 3.5 bar can directly fit to the atmosphere, can directly fit to the hospital line, wherein it can be fed to the patient directly now. We don't have to have cylinders anymore.
But to meet that challenge, can these LPG cylinders be converted into?
Yes, I think Tata Consulting Engineers had done some standardization, because we got standardizations and all that thing required to be done.
Yeah.
And they allowed during this time, may not be for all the time, but they allowed for this time when we had a scarcity of cylinders, that LPG cylinders also could be used for oxygen purposes.
Okay. Thank you.
And then you have to be very much aware of what pressure you are putting in on all that thing, because common technicians were not well trained for this.
Yes. Thank you.
Yeah, thanks a lot, sir. Thanks a lot once again. Thanks everybody, and good day, good night, bye. Thanks a lot. Okay, I declare this event is closed now. Thank you very much. Thank you, sir.
Thank you. Anyone meetings Suraj acknowledge केलं मी माझं नाव घेऊन.
Hello, Uday.
हाँ बोल.
Wonderful session. And good contribution from your end also.
Yes, thank you so much.
This PSA plant, automation things we are doing in our factories.
Okay.
And that too, we can handle it remotely now. Means we need not go to plant site always. Small problems and other things, if they can get it through Wi-Fi or so, we can very easily able to control it.
If you want,
and
you can push this your product through Dr. Atrey's what you can say contacts and everything. एक मिनिट
Okay.
hold on. एक
Yeah,
मिनिट चालू ठेव फोन. फोन चालू ठेव.
Pardon? हॅलो.
हा बोल.
हा, आपण एकदा अत्रे सरांशी बोलून घेऊ नंतर.
एक मिनिट. काय म्हणलं?
नंतर बोलून घेऊया आपण अत्रे
नाही नाही,
सरांशी.
अरे एक मित्र अजून एक पार्टिसिपंट होता. मी आता नाव बघितलं, विजय शिंदे म्हणून, त्याचा फोन होता.
अच्छा, ओके ओके.
तो तुमच्या पॅनलवरती मला माहित नव्हतं.
हा, म्हणून मी तुलाही म्हणलं होतं मागे, पण यू कुड नॉट फाइंड टाइम टू जॉईन अस. नाव यू कॅन थिंक ऑफ.
येस येस डेफिनेटली. आणि आता नाव मी ऐकलं मगाशी, आनंद मारुकर. तो म्हणजे तुमचे गेस्ट लेक्चर होता, तो गेस्ट लेक्चर होता की इज ऑन युअर
ही
पॅनल?
इज ऑल्सो वन ऑफ आवर मेंबर. आणि ते आम्हाला ते आमचं रिकव्हरी क्लिनिकचं जी सिस्टीम आहे आम्ही जी इम्प्लिमेंट केली आहे, दॅट ही हँडल्स.
कारण ही स्टेज इन माय बिल्डिंग ओनली. आम्ही शेजारी शेजारी आहे.
अच्छा, ओके ओके.
एकाच ठिकाणी राहतो. मी
बरं,
नोईच्या.
बरं. ते कसं आहे, त्यांचं बॅकग्राऊंड ते पण IIT इंजिनियर आहे आणि नंतर त्यांनी लॉ पण केलंय.
लॉ केलाय. हो, राईट राईट.
अँड दॅट हेल्प्स मेनी इंडस्ट्रीज इन दोज वेज. नाही, त्यांना इंजिनिअरिंग बॅकग्राऊंड विथ लॉ
हो
गिव्स अ ब्युटिफुल सोल्युशन्स.
हो हो.
मग ते आमचं आता ही इज ऑल्सो अवर मेंबर. तर ते
हम्म.
आता रिकव्हरी क्लिनिक ते सगळं हँडल करतात. म्हणजे जे काय असेल, आम्ही महिन्यातनं 2 शुक्रवार घेतो ते.
अच्छा.
कुणाचे काही कंप्लेंट्स असतील काय असतील तर, अँड देन अकॉर्डिंगली वी डिसाइड अँड ट्राय टू सॉर्ट आउट दॅट. सो ही गिव्स ऑल द लिगल इन्फॉर्मेशन अँड गायडन्स अँड एव्हरीथिंग.
ओके ओके. ते म्हणलं, तुला जर तुझं हे ऑटोमेशनचं प्रॉडक्ट आहे रिलेटेड टू PSA वर जर तुला प्रमोट करायचं असेल ना,
हा,
तर आपण अत्रेशी एकदा बोलू सेपरेटली.
ओके.
आणि त्याच्याकडनं घेऊ आपण गाईडलाईन्स काय करता येईल पुढे, नाही का?
येस येस, डेफिनेटली. आय विल कॉल यू बॅक.
चालेल.
चलो, ओके.
Yes.
गुड नाईट.
ओके, गुड नाईट.
थँक्यू. गुड नाईट.
थँक्यू. गुड नाईट.
अमर, गुड नाईट.
आणि